Express 2.13 in the form a over b, where a and b are integers. And so any number that can be expressed in the form a over b is a rational number. So what we want to show is that this number here is rational. So what I'm going to do is I'm going to get this number and equate it to x. So I'll just say let x be equal to 2.13, and we know that 1 and 3 is repeating, so I need to pay particular attention to where the bar is starting and where it is ending. And so at this point I make sure that first my decimal point is in front of the repeat number. In this case the repeat number is, the first one is 1, so the decimal point should always be in front of that. And then next I'll make sure that it goes behind the last number which is repeating, and that is a 3. And how do I get to do that? So if this is my equation 1, and then I'll say I'll multiply equation 1 by multiples of 10, but how many times can I move this decimal? 1, 2, it should be behind there, so I need to multiply by 100 so that the decimal goes behind. So that will be x multiplied by 100, that is going to be 100x. And 2.13 multiplied by 100, that will be 213. The decimal point will come here, but since this number is repeating, I'll just write it again and still put a dash there. Now that I've got this, I'm now going to subtract. I'm going to subtract, let me call this equation 2. So I'll say equation 2 minus equation 1. So I'm going to write equation 2, that is 100x being equal to 213.13, and this is repeating, and we have got x which is equal to 2.13 as equation 1. So getting to subtract this, 100x minus x, that is going to be 99x, and that will be equal to, well, as we get to subtract this, these two portions are going to cancel. So I'm going to write it as 213.13. This is repeating. I'll put a decimal point here. This is also 13 repeating, and then you have got a 2 here. So whenever we subtract the same thing, it always cancels out. So that is going to go. And then 3 minus 2, that is going to give us a 1. And then you have got another one, and then a 2. So this will be 211. Therefore, x is going to be 211 divided by 99. So we have expressed in the form a over b, where a and b are integers, and for this one we cannot simplify further because there's no number that can go into 211 and 99 without a remainder. Let's consider this one. Express 4.357 in the form a over b. Now here the number that is repeating, the first one is 5, and then we have got a 7. So to express this one also in the form a over b, we'll just say let x be equal to 4.357. So 5 and 7 are the ones which are repeating. The first thing I'll make sure is that the decimal point goes in front of the first number which is repeating. And how can I take it there? So let me call this as equation 1. I need to multiply equation 1 by 10 so that the decimal point can move once. And that will be 10x being equal to 43.57. Let me call this equation 2. And when I'm already made sure that the decimal point is in front of the repeat number, I need to also make sure that it is behind the repeat number. How many times can I move it? 1, 2. So I should move it twice, and I should multiply the second equation. So I multiply 2, that is equation 2, by 100 because I want it to move twice. And starting from here, 10x times 100, that is going to be 1000x. And that is going to be 43.57 times 100, that will be 43.57. The decimal point will come here. Now because this term is repeating, I'll just put it again here and put a bar. This will be the third equation. So here what I'm going to subtract is not equation 1. I'm going to subtract the 2 where first the decimal point is in front of the repeat number and also behind the repeat number. Those are the two that we get to subtract. So we are going to say subtract 3 minus 2. I'll write that 1000x is equal to 4357.57, repeat, and we have got a 10x which is equal to 43.57, repeat. So what is 1000 minus 10? So that is 990x. And now the other side we have got 4357.57. This is repeating. I'll put a point here and then 57, which is repeating. I'm going to put a 43 here so that I get to subtract them. If we get to subtract this, we're going to get zeros. So 7 minus a 3, that would be a 4. 5 minus 4, that would be a 1. And then we have got a 3 there and then a 4 there. So that is going to be that when we get to subtract them. Then I'm going to write 4314. And I'll divide both sides by 990. So this will be 4314 divided by 990. So do we have a number that can go into 990 and 4314 without leaving a remainder? So 6 can. We can take 6 into this one on top. That is going to give us a 719. And 6 into 990, that would be 165. So this is the simplest form of this fraction. Then we've expressed it. Let's consider this one. Express 1.514 in the form A over B. Now here it is 4 that is only repeating. The rest are not repeating. Again, we say let x be equal to 1.514. So 4 is repeating. I need to make sure that I take the decimal point in front of the repeat number. That is in front of 4. So I need to move the decimal point only twice. So this is equation 1. I'm going to multiply it by 100. Multiply 1 by 100. So that is going to give us 100x being equal to 151.4. Therefore, that is repeating. That will be a second equation. Now that we've got this, I need to make sure that the decimal point is behind the repeat number. And how do I make sure that it is? I need to multiply by 10 so that the decimal point goes there. So we'll say multiply 2, that is by 10. So 100x times 10, that is 1000. And then 151.4 times 10, that will be 1514. I'll just put a decimal point there and put the number that is repeating. This will be the third equation. So I'm going to subtract equation 3 and equation 2. So 1000x is equal to 1514.4. And then there we have got 100x, which is equal to 151.4 also. So 1000 minus 100, that is 900. And that will be, we have got 151.4.4, and we have got, I'll put a point there, 4, we've got 151. Subtract those. These two are going to cancel out. 4 minus 1, that is a 3. 1 minus 5, we can do that. So I will remove a 1 from here to remain a 4, and that goes into 11. So that would be now 11 minus a 5, which is a 6. And then 4 minus a 1, that is a 3, and then you've got a 1. So this will be 1363. Now at this point, we're going to divide both sides by a 900. So x is going to be 1363 divided by 900. We know what x is. X is this part. So we've expressed this part in the form a over b, and there's no number that we can take into any of those to give us no remainder. If not, it will take us back into decimal. So that is going to be it for that one. So let's consider question number 4. Want to express 1.4545 in the form a over b, where a and b are integers. Again, we'll let x to be equal to 1.4545, repeat. So the only thing is we need to make sure that the repeat number is always in front. I mean the decimal is always in front of the repeat number and behind the repeat number. Now if we can look at this one, even if it is this 45 which is repeating, we still have a 45 here. So this is as good as writing this as x is equal to 1.45 and then put a dash here, because this is 45 and this is 45. The 45 is repeating. The meaning of 45 repeat like that. This means we're going to have 45, 45, 45, just like that, and we already have also a 1 in front, so it's not different writing it in that other form that I've written it. So since it's already in this form, all I'm going to do is to take the decimal point behind there. So that is going to give us, how are we going to do it? Let me call this equation 1. So I'm going to multiply equation 1 by 100, and that is going to give us 100x being equal to 145.45. Repeat, so be equation 2. And then at this point now we're going to subtract 2 minus 1. As long as we've made sure that the decimal point is in front of the repeat number and behind the repeat number, we can surely subtract. So this is going to be 100x, which is equal to 145.45, and then x, which is equal to 1.45. This is repeating, this is also repeating. So 100x minus x, that will be 99x. And we've got 145.45, and we have also 0.45 there, and then we've got a 1 here. We get to subtract this. So 5 minus 1, of course this will cancel out, so 5 minus 1, that is a 4, and then there's a 0 here, there's a 0, that will be just 4, 1, so that is going to be 144. So at this point what we're going to do is just get to divide 144 by 99. Okay, so this will give us 144 divided by 99. Do we have any number that can go in any of these without giving us a remainder? So what if we consider 9 itself? 144 divided by 9, that is going to be a 16, and 99 divided by 9, that is going to be 11. So this is the simplest form in which we can leave this one. Thank you so much for watching. Enjoy your day.